A breakthrough on the first law of thermodynamics. Thermodynamics has been a cornerstone of chemistry and physics for over 200 years, but its limitations have remained unchanged. Thermodynamics is a cornerstone of chemistry and physics and has been since the 1800s. It is the first law of thermodynamics that states that energy can only be converted from one form to another, but its limitations have remained unchanged for over 200 years. Recently, however, scientists have made major advancements in understanding how to break this law, which may lead to new technologies and products. What is the new finding that solves the problem of entropy increase? A new finding solves the long-standing problem of entropy increase. Entropy is a measure of the disorder or chaos in a system. The more entropy there is in a system, the less organized it is. The first law of thermodynamics states that entropy cannot decrease over time, meaning that systems tend to become more disordered over time. This was a major limitation on how scientists could study systems, as they could not see how they got more disorderly over time. However, a new study published in Nature has found a way to circumvent this restriction. By using light instead of heat to probe the system, scientists were able to see how entropy increased and then decreased. This allowed them to study systems at very low temperatures, which had not been possible before. What is the new theory that is based on the third law of thermodynamics? Thermal energy is a type of energy that can be converted into other forms of energy, such as kinetic or potential energy. Thermodynamics is the study of the laws governing the transformation of energy from one form to another. One law of thermodynamics, known as the first law, states that energy cannot be created nor destroyed, it can only be transferred from one object or body to another. The second law of thermodynamics states that entropy, a measure of disorder, increases over time. Entropy is a measure of how much information about the system is lost. A third law of thermodynamics has recently been proposed and could provide a breakthrough on an age-old limitation in the understanding of the first two laws. What are its implications? Its implications are far-reaching and could fundamentally change our understanding of the universe. In the early 1900s, scientists developed a theory that explained how heat flows between objects. The theory was called the first law of thermodynamics. This law states that in an isolated system, the entropy of that system will always increase over time. Entropy is a measure of disorder and chaos in a system. It's important to understand entropy because it's one of the few constants in nature. The first law of thermodynamics is an empirical law, which means that it can be tested and proven using experiment. Until recently, scientists thought that the first law of thermodynamics couldn't be violated. But now, they've found a way to do it. They've demonstrated that entropy can decrease in systems where energy is transferred from hot to cold objects. This discovery has far-reaching implications for our understanding of the universe and could lead to new ways to create energy or store energy. The discovery was made by researchers in Europe and is currently under review for publication in a scientific journal. A team of European researchers has made a discovery that could fundamentally change our understanding of the first law of thermodynamics. The law, which states that energy can neither be created nor destroyed, has been a constraint on scientific understanding for over 150 years. But this recent discovery may have finally overturned that limitation. Conclusion. The new finding comes from studying the decay process of radioactive elements. By observing how these elements break down and release their energy, the researchers were able to determine that some forms of energy actually do create new particles in their wake. This means that the first law of thermodynamics may not need to be held as strictly true. After all, it might just be restricted to a certain subset of situations. If this is confirmed by further study, it would represent a major breakthrough in our understanding of the universe and its workings.